Okay, hello everyone. So in this video, we'll begin on the first topic in physics, okay, which is the topic on physical quantities. Okay, so yeah, let's just uh, learn what is the definition of a physical quantity. Okay, a physical quantity is a quantity that can be measured. Okay, so it's basically something that can be measured, huh? So in contrast to a non-physical quantity, okay, for example, non-physical quantities cannot be measured. Okay, so examples would be, for example, intensity, color, or human emotions. Okay, so a physical quantity can be measured, and usually it consists of a magnitude, a numerical magnitude, okay, and a unit of measurement. Okay, this is quite important. Okay, uh, basically you just got to know the numerical magnitude is pretty it's quite common sense, because this is just telling you how much is the quantity. But more importantly, we have to understand that it has a specific unit. Okay, and this is very important, because you have to remember what is the uh, correct unit for different types of measurements. Okay, so let's just go into understanding what is a base quantity and a derived quantity. So a base quantity, as the name suggests, okay, is, for example, like they are sort of like the basic quantities that you can always reproduce them accurately, and they do not change with time. Okay, whereas a derived quantity is basically a quantity that's derived from a base quantity, right? So for example, base quantities will be mass, length, time, electric current, and temperature, for example, right? So what it means by you being able to accurately reproduce it will be if you measure the mass of a substance, for example, okay, uh, by using a weighing scale, okay, for example, you can or beam balance, for example, you can uh, obtain that same measurement for the mass, okay, accurately, okay, and it remains the same, right? Like the mass of the substance, whether you measure it now or later, it is the quantity of that mass is the same, right? The magnitude of the mass remains the same, right? So that is a base quantity, okay. Uh, so it's not to say that a derived quantity will uh, be changing with time, okay. It does not mean that, okay, but what it actually does is just it defines base quantity, okay, as something that's accurately reproducible and is unchanging with time. And based on this definition, a derived quantity is basically a quantity that's derived from one or several base quantities, okay. So here we will actually learn what is something called the SI unit. Okay, very important. SI units are basically an internationally recognized set of units. Okay, what its purpose is basically to prevent confusion. Okay, so they actually standardize the unit, so everyone is on the same page as to what are the numerical magnitudes or quantities that they are talking about. So the SI unit will be kilogram, length will be meters, okay, time in seconds, electric current is amperes, and temperature is in Kelvin. Okay, so you have to memorize all these SI units, right? It's just how it is, and just got to remember that. And a derived quantity that's derived from a base quantity will be, for example, density, which is derived from mass, okay, and volume, whereby volume is actually derived from the length. Okay, so basically density is mass divided by volume. Okay, so density is a derived quantity, right? So derived unit will be kg m to the power of -3. Okay, this is basically by doing some mathematical manipulation of the SI units within this formula. Okay, you'll be able to derive this, right? So mass is kilogram, that's why there's a kg over here. V volume is actually we know that V equals to, okay, length times basically it's length times length times length. because a breadth or height, they are actually basically the same thing, they are lengths. So the unit for volume is actually meter cube. Okay, but because it's at the denominator, so you will learn in mathematics that it will be actually there's a -3 over here, because it is not part of the, it's part of the denominator and not the numerator, right? So a meter cube, you add a negative and it becomes a m-3. Okay, so that's how you derive the units. So speed, for example, is another derived quantity, whereby speed is distance divided by time. Okay, so distance SI unit is meters, time is in seconds, but because it's at the denominator, so it is you add a negative sign, so it's second minus 1. Force equals to ma, right? So force is a derived quantity, whereby it's mass times acceleration. Okay, mass will be in kg. Acceleration is ms minus 2. Okay, the unit for ms minus 2, okay, is derived from speed. Okay, because when you subsequently we'll actually go more in depth into the how we actually get the units for example acceleration. Okay, but as of now, just know that acceleration is ms minus 2. Okay, so acceleration will be ms minus 2. Okay, while mass is in kg. Right, so mass is in kg and acceleration will be ms minus 2. Okay, but do know that as in just like how we actually derive the units for density, okay, mathematically we can actually derive all these units from, okay, the formula itself, right? They are consistent with the formula. Okay, so pressure is force over area. Okay, over here it is the simplified form for the derived unit is kg m minus 1 s minus 2. Okay, here is a little bit more complicated, right? The formula. So we'll actually not go in depth into it. Okay, but just know that pressure is a derived unit because it is obtained from force and area, right? Force itself is a derived unit and area as well. Okay, so they're all derived from base units, right? And work done is also a derived unit. Okay, whereby work done is force times displacement. Okay, force times distance basically, or displacement, right? So F represents force, S represents displacement. So this is once again a derived quantity. Power is work done over time. Okay, so once again it's a derived quantity, and electric charge is current times time, right? So here basically you do not, I just gave you the derived units, okay, as a form of it's good to know, okay, but as of now you do not actually have to go in depth to derive them. Okay, what's more important is you got to know what are the SI units. Okay, so SI units for force will be Newton, for pressure will be Pascal, okay, work will be Joule, power will be watts, and electric charge is in coulomb. Alright. As for the formulas, right now you do not have to fully understand how these formulas are obtained, because you'll be learning, going in depth into all these in separate topics later on. Okay, so you don't really have to know what are all these formulas right now. Okay, just take note of just know the difference between the base quantity and the derived quantity. Okay, and what are the SI units of all these quantities, right? So now we'll go on to what are prefixes. Okay, so prefixes are for example, like if let's say mass, let's look at this example, mass equals to 45 kg. Okay, the gram here is actually G actually represents gram. Okay, gram is actually a base unit. Okay, and the K represents kilo. The kilo is actually a prefix. right? So a kilo is actually a preceding factor, okay? So it's something that comes before a base unit, so that's why I use the word preceding. Factor, okay, so why is it a factor? Because it acts as a multiplier of a base unit, right? So for example, kg represents 1000 grams, so it actually multiplies the base unit, which is grams in this case, by 1000, right? So the prefix kilo, okay, what it does is actually multiplies grams, which is the base unit, by 1000, right? So what is a base unit? A base unit is simply, in other words, previously we have learned this definition, but another way to look at it is that base unit is simply a unit without a prefix. Okay, so it is just something that, for example, gram has no prefix, so it's just a base unit, right? So because kilo represents multiplication of 1000, so it's actually a multiplier factor of 10 to the power of 3, right? 10 to the power of 3 is actually the same as 1000, right? So here there's a table that are provided. Okay, if you look at the different prefixes, okay, they will actually have different factors, right? So for example, nano, the symbol is n, factor is 10 to the power of minus 9. So if I have 1 nanometer, it's actually 1 times 10 to the power of minus 9 meters. Okay, so micro 10 to the power of minus 6. So 1 micrometer is 1 times the factor, which is 10 to the power of minus 6, and so on and so forth. Right. So here we have a table of prefixes and the factors of multiplication that they represent, and how you actually, okay, if you actually have a quantity that includes a prefix, okay, how do you express it? Okay, so basically the prefix itself, you can replace it with a factor, right? So 1 nanometer is 1 times 10 to the power of minus 9 meter. You replace the n here, okay, with the factor 10 to the power of minus 9, okay, because that's the factor for nano. Okay, so you do the same for all of them. Okay, you'll be able to get all of these values. Okay, so now we will learn about conversion. Okay, so how do we convert a prefix unit to a base unit? Okay, so there are two types of conversion actually. Okay, if you actually just simplify everything, okay, try to sort of generalize them. Okay, you either convert a prefix unit to a base unit, or the other way around, you convert a base unit to a prefix unit. Okay, so if you're converting a prefix unit to a base unit, okay, for example, you want to convert 3.5 micrometer, which is a prefix unit because there's a micro there, so it's a prefix unit, to meters. Okay, meters is actually, there's no prefix, right? So it is this meter over here is a base unit. Okay, so it falls under the situation whereby you're converting a prefix unit to a base unit. Okay, so what do? You multiply by the factor of the prefix. Okay, you do a multiplication. Okay, you multiply. Okay, so 3.5 micrometer, okay, I want to convert this micro, replace it with this 10 to the power minus 6, okay, because in this table here, we have micro is 10 to the power minus 6. Okay, as you can see here, okay, micro is 10 to the power minus 6. So, we replace micro with 10 to the power minus 6, but we do a multiplication, right, because we multiply by the factor. Okay, so how do we convert 3.5 micrometers to meters? Okay, this is a prefix unit to a base unit. We multiply by the factor of the prefix. On the other hand, if we want to do the other way around, converting base unit to prefix unit, okay, we just do a divide. Okay, so if here micrometers to meters, I do a multiplication, then meters to micrometers, okay, base unit to prefix unit, instead of doing multiply, I will do the reverse. I will actually divide. Okay, so logically it is just doing the reverse, right? If I'm converting prefix unit to base unit, I multiply. If I'm doing the reverse, base unit to prefix unit, I do a division. Alright, so an example, okay, expressing 450 grams is a base unit because gram has no prefix, okay, to kg. Kg is a prefix unit because there's a kilo there, that's the prefix. So I'll divide by the factor of the prefix. So kilo, I know that kilo, as you can see, is 10 to the power of 3. Okay, that's the factor that it represents. So I replace the to convert gram to kilogram, okay, the kilo represents 10 to the power of 3. So it will be a divide by 10 to the power of 3. Okay, so you divide by the factor of the prefix, right? So 450 gram equals to 450 divided by 10 to the power of 3 kg, and it will be 0.450 kg. Okay. Okay, so here I just put a small note here, okay, which is that it's very important to note that a base unit is not the same as a SI unit. Okay, why is it so? Because SI unit in this case, as you can see, previously we have learned that the SI unit for mass is kilogram. Okay, but the base unit is gram, correct? So you cannot sort of automatically say, or you cannot just make the assumption that a base unit is always the same as SI unit. Okay, because in the case for mass, the SI unit is actually kilogram, but this has a prefix to it, right? So the base unit is actually gram. Okay, so the SI unit for mass is different from the base unit for mass, right? This is because the definition of a base unit is simply a unit without a prefix. Okay, so that explains why the SI unit can be different from the base unit. Okay, so standard form. Okay, basically, if you learn in E-math as well. Okay, standard form basically is you're writing it in this form whereby it's a certain number multiplied by a certain order of magnitude. Okay, so this number over here, it is a number that is between 1 and 10. Okay, so it can be like 1.01 to 9.99, right? But it cannot be 10 or it cannot be 1. Okay, and definitely it cannot be smaller than 1 or bigger than 10, right? And this is just the way this form works. Okay, so you just have to know that to express it in standard form, this number here has to be between 1 and 10. Okay, it can be up to 2 decimal place or 3 significant figures. And here will be basically is a power of 10, right? So in this case, it will be 10 to the power of 23. It can be 10 to the power of 1, 10 to the power of 2, 10 to the power of 10, you know, but just know that it's 10 to the power of something. Basically, it's what you call it is a power of 10. Okay, so this is how you express something in the standard form. Okay, so now we'll just talk about what are scalar quantities and vector quantities. Okay, so scalar quantity is something that only has a magnitude. Okay, but a vector quantity has both magnitude and a direction. Okay, so a vector quantity usually it will be in the form of a line. Okay, whereby the length of the line will represent the magnitude of the value. Okay, so for example, if I have a line like this, okay, this length over here will represent the magnitude, and the direction of this arrowhead will give me the direction of the vector, right? So just know that a vector quantity is usually expressed in the form of a line. Okay, so examples of scalar will be all this distance, speed, time. So all these values here only have a magnitude and no direction. And vector is all these values here, they have both a magnitude and a direction. Okay, so how do you manipulate scalar quantities? You only do addition or subtraction. Okay, you only plus or minus the magnitude. That's it, very simple. But for vector quantity, there must be vector addition or subtraction. Okay, and there will usually be a resultant because of a change in direction. Right, so vector addition or subtraction, what does that mean? Okay, so vector addition or subtraction can be done using two methods. Okay, one you call it the parallelogram method, and the other one called the tip to tail method, but they are essentially the same. Okay, so vector addition, what you do is, for example, let's say if I have a vector A and a vector B, okay, vector A is going in this direction, vector B is going in this direction, right? So parallelogram method, it means that I will draw a parallel line, okay, to B, okay, so B is over here, right? So there's a parallel line over here, okay, and for A there's a parallel line over here. Okay, so what happens is that, okay, this will form a parallelogram because if I draw a parallel line with the exact same length, okay, it's actually the same vector, okay, and if I draw once again for A, a parallel line in the same direction, okay, it's the same vector, okay, and then it will form a parallelogram, okay. Why is it a parallelogram? These two lines are parallel, these two lines are parallel, and the diagonal will be the resultant force, okay. So if I add vector A with vector B, what I will get is resultant force, okay, which is over here, right? This is the resultant force, which is A plus B. Okay, so the reason why there's a resultant force is because we are also taking the direction into account. Another method will be tip to tail, whereby I will just shift this vector B up to this portion here, okay, this line here, which is the parallel line of the same length, and then what I will get is a tip to tail, whereby the head of A will join to the tail of B, okay, and the resultant force will be the tip all the way to the tail, right? So so this is the end, okay, of A. This is the head of A, the tip of A. It joins to the end or the tail of B, okay, and this is the head of B. So the resultant force is from the tail of A all the way to the tip of B, right? So this will be the starting point and the ending point, because imagine like I'm walking from here all the way to here, and then I'm walking from here all the way to here. The overall direction that I'm moving is just simply from here to here, right? So this is the resultant force.